Hello everyone, welcome back. In this video, we'll be discussing about the last problem of today's biweekly contest, maximum number of K-divisible components. The problem states that you are given an undated tree with n nodes labeled from 0 to n minus 1, and you are given an array values which denote the value associated with the ith node, and finally you are given an integer k. Now you need to split the tree into maximum number of components. Any split is not valid. A valid split is defined as the split where the resulting components all have values that are divisible by k. Now the value of a component would be defined as the sum of the value of all the nodes in that particular component, right? So our task is to divide the tree into maximum number of components. So let's take an example. Let's say this is a tree, right? And in this tree, what we can do, we can just remove this edge and divide this into two components. First, which have 2, 4 and 0. Second, which have 1 and 3. Now if you look at the first component 2, 4 and 0, this should be divisible, the value of this should be divisible by 6, and the value of the second component 1 and 3 should also be divisible by 6 for this split to be a valid split. Now here if you sum the values of 0, 2 and 4, the value of 0 is 1, value of 2 is 1, and value of 4 is 4. So 4 plus 1 plus 1, which is 6, which is divisible by k. And similarly, if you sum up the values of 1 and 3, the value of 1 is 8 and the value of 3 is 4. So sum is 12, which is again divisible by 6. So because the individual components values are divisible by k, this split is a valid split. So we found a split with, we found one valid split which have two components. Now you can try any other possible split. You will not be able to make more than two components where each components are valid, and hence the answer here is 3. Answer here is 2. So hope the problem statement is clear. Now how to solve this? So before solving this problem on tree, let's simplify it and let's try to solve the same problem on an array. So let's say you are given this particular array and you have to solve exact same problem. Basically you have to divide this array into sub arrays such that each sub array is divisible by k. So if you were completely stuck in the previous problem, this is a very good small follow-up, a small problem that you can solve. So I would encourage you to pause and try to solve this particular version by yourself. So think about it, where we have to start from here, like 0 should be a part of some component, right? So we have to start our first component from here. Now where should we end it? Let's say k is 5, right? So basically we want all the splits to be divisible by 5. Now if you take this as a component, this component has just one element which is 0, and it is divisible by 5 because the value is 5, so 5 is divisible by 5, so this is a valid component. Now you can see this is also another valid component, right? So 9 plus 9 18 plus 7 25 plus 5 30, so 30 is also divisible by 5. Now which of these two components should you make 0 a part of? Either, like, do you want 0 to be part of this component, or do you want 0 to be part of this entire component? The answer is simple. You want 0 to be part of the component which is as small as possible, so that you can make more components. For example, let's say you make 0 a part of this component. So what you are saying is, starting from here all the way up to, let's say, j, we found that the sum is divisible by 5, right? And what we are saying, there is another I which exists in between, and the sum between 0 and I is also divisible by 5. So if this is divisible by 5 and this is divisible by 5, we are sure that this piece itself would be divisible by 5, right? And because that's the case, why would you want to waste one component which you are getting for free? Basically, you can say, instead of making this entire piece as a component, I know I will be able to make this as a component, and then this can be another component, right? So the logic is simple. We will keep on we will keep on taking the elements until we can find a position where it is divisible by k. As soon as we find such position I, we will stop, and that will be my first component, and from there onwards next component will start. So in this particular example, we will start from 5, right? So this will be our first component, because up till 0 itself we found a component which is divisible by 5. Now next component would start from here. Now we will keep on doing this. We will keep on taking elements. So 9 plus 9 18, not divisible by 5, plus 7 25, divisible by 5. So we will end our component here. Now next component will start from here, right? And again 1, not divisible by 5, 1 plus 7 8, not divisible by 5, 8 plus 8 16, not divisible by 5, 16 plus 4 20, divisible by 5. So we will stop our component here, and next component will start from here, and finally this 2 will be a part of the last component. So we found we can split this given array into at max 4 components, and there is no better answer, right? So hope the solution on this array is clear. If it is not, I would strongly encourage you to rewind the past 2 minutes of the video and try to understand this piece before moving forward. So next, let's try to solve this on the tree. Now before jumping into a very big tree, let's try to simplify and solve it in a simplest tree with branches. So if the tree doesn't have branches, the problem is straightforward. But if tree has branches, so basically if let's say tree is like this, no branches, just a single kind of linked list. So this is nothing but an array, right? And we already saw how to solve the problem on an array, right? So now let's take a tree with some branches, and the simplest tree possible with some branches is a single root node with some leaves or some children, right? So we have 2 trees here. Let's focus on the first one first. So here we can see 4 is the root, so this 4 is the value. I'm not depicting the actual ID of these nodes, because what matters is the value, right? So this 4 is the value, 5 is the value, 6 is the value, and 15 is the value. Now we want to maximize the number of components or number of pieces that we can get out of this tree, right? So the same concept again, we will keep on taking pieces until we can, and we will stop at the very first position where we show that the component that we have is divisible by k. Again, k is 5 here. So in this case, we can see there are 2 leaves which are in itself divisible by 5. So these 2 leaves can be a part of one component independently. So basically we can remove this edge, and this 5 will be one component, and similarly we can remove this edge, and this 15 can be one component. So we found one component here, one component here. Now the remaining is 4 and 6, and we can see 4 plus 6 is 10, and this can be one extra component that is possible. So in total we found 3 components, right? Now what we have done here, we have simply figured out which of the leaves are itself divisible by k, and simply remove them from the picture, right? Now let's take one more example. Let's say this is the tree. In this case, we can see none of the children has a value which is divisible by 5 or divisible by k, but you can see that 7 and 8 are divisible by k, and 4 plus 6 are divisible by k. But the point here is you can't take 7 and 8 in one component in which 4 is not there. So what we are saying here is 7 plus 8 is 15, which is divisible by 5. So the best possible choice here could be bring 7 and 8 into one component, and 4 and 6 into one component. But the problem here is for 7 and 8 to be in one component, you have to have 4 in that component, because 7 and there is just one path between 7 and 8, because the given structure is a tree, so there is just exactly one path between 7 and 8. And if you want 7 and 8 to be connected or in a single component, you should have all the nodes in that particular path. So in this particular case, 7 and 8 are passing through 4, so 7, 4 and 8 should be in a single component if we want 7 and 8 to be in one component, right? So what we are seeing here is we have to take 7, 4 and 8 in a single component. But if you take this, you can see the given component is not divisible by 5. But if you have not taken 4, it could be, but you have no other choice but to take 4. So the given component is not divisible. But if you take 6 as well, the given component is divisible. So basically in this case, you will not be able to divide the tree into any components, and there will be just one component, which is the complete tree itself, right? So what is the observation? The observation is, if the leaf itself is divisible, you can simply remove it. There is no restriction there. But if leaf is not divisible, it means it should be merged with something else. So in this case, 7 is not divisible, so 7 should be merged with something else. Now that something else must pass through its parent. There is no other choice, right? So what you can say is, okay, if 7 is not divisible, I will simply forget about 7 and I will update the value of the root as 11. The answer for this structure will exactly be equal to the answer for the original structure where we had 7. Okay, and the reason for that is because 7 itself can't be part of independent component, so it should be part of some other component, and that some other component will be passing from root. So basically 7 will be merged with the root anyways, so let's just remove 7 and make the value of the root as 11, right? Now the same thing, let's do the same thing for this node. 6 is 6, or can 6 be a part of single component? The answer is no, right? So again, if 6 can't be a part of single component, there is no point taking 6 at all. 6 has to go through the parent, and hence we will just merge 6 as well into the parent. Now finally 8, can 8 be a part of single component? Answer again is no, so we'll just simply remove this and make the value of the parent and merge it with the parent and increment the value of the parent itself. So the value of the parent now is 25, and can 25 be a part of single component? The answer is yes, so this is a single component. And notice that you don't need to answer which component or which nodes are the part of the component, so it's still fine if you keep it merged and not trace back and figure out which of the nodes are there in this 25. That is easy to do, but for now, for this problem, that is not required. We just need to figure out the total number of components, right? So hope this point makes sense. Now let's finally solve the problem on a bigger tree. So again, these are all the values of the nodes, not the IDs of the node, and we want to find out the maximum number of components, right? So the same strategy will start from all the way to the leaf. So 5, is 5 divisible by k? K again is 5, so answer is yes. So 5 can be a part of one component, so this is one independent component. So in other words, we will remove this edge. So let's just keep on doing that. Now next child is 3. So is 3 or can 3 be a part of independent component? Answer is no. So there is no point. So 3 can't be a part of independent component, so it has to go and merge with something, and to go and merge with something, it has to go through its parent, because there is no other way, right? And that's where you will simply remove 3 and make the value of this node as 7, right? Now again, with 7 you will answer the same question, is 7 a part of, or basically we are now looking at this particular subtree. but for this particular subtree we have to first make this tree equivalent to uh, a single node, because otherwise we know how to solve the problem in this structure, right? So we are trying to make everything to this structure and then solving the problem. So we first saw that this was the same structure, so we solved here. Now we are trying to solve for here, but here this has more children, so let's just try to boil this down. So is 15 can be a part of same component? Answer is yes. So let's just make 15 a part of single component and remove this edge, right? Can 20 part of single component? Answer is again yes. So let's make 20 a part of single component and remove this edge. Now finally we are left with 1. So again you can see this is exact same structure that we know how to solve for. So let's try. Can 7 be a part of same component? Answer is no. So this 7 will be merged with 6. Now this will be changed to 13. Now notice that this 7 was not 7 itself, it was 4 before and then 3 was merged, but it doesn't matter because you know that the other node will go with whatever node this parent will go with, right? So that's where we are freely merging this entire 7 into the parent. In other words, whatever component will have, this will be the nodes that will be part of that component, right? So let's just remove these nodes and make 7 a part of this, which is 13 here, right? Now can 1 be a part of same independent component? Answer is no. So let's just merge it with parent and get rid of it. So let's get rid of it. Again this one can't be a single component, so let's just get rid of it and make it 15, right? Now again let's solve for other things. So this can be a part of same is independent component, let's keep it aside. This can be a part of independent component because it is 0 to the 5, so let's keep it aside. This cannot be a part of same component, independent component, so we have to merge this with parent. So let's just get rid of this and make the value of parent as 9. Now finally we are left with this structure which we know how to solve again. So is 15 or can 15 be a part of independent component? Answer is yes. So let's just remove this edge and 15 will be there. Now notice that this is not only 15, this is a combination of some nodes, right? But we don't, like, we can find out the which exact nodes are the part of this component, but for this problem it is not required. So this is the independent component. Now 4, can 4 be a part of independent component? Answer is no. Let's just get rid of 4 and make it 6. Finally, can 9 be a part of independent component? Answer is no. Let's get rid of 9 and make it finally 15. Now finally 15 can be a part of independent component, so this is another component. So in total we found 1 2 3 4 5 6 7 components, and 7 is the answer. So hope this entire thing makes sense. If you have watched to this point, I would strongly encourage you to pause and try to code this entire thing by yourself, because otherwise you will not able to understand. If you are not able to code this, it means you are not able to understand some of the piece which you should be. So I would encourage you to pause and try to code and get it submitted in Leetcode. So next we're looking at the code. The code is straightforward. What we have discussed is exactly what we have written in the code. So we build the adjacency list, right, and of the given tree, and now we are just running a DFS. Now this DFS is simple. We are iterating over all the children and first figuring out the leftovers from the children. So we are saying that okay, first go and solve for all the children, because we know we can solve for a single root with some child, not more than that. So we are first solving for all the children. Now once we have solved for all the children, we will be having some leftover, right? So for example, in this particular case, if you remember, this was the structure previously, right? So basically there was some leftover from the processing of the children. So this leftover is what we are adding to the parent, right? Now finally, after we have added all the leftovers to the parent, we'll just check if leftover is divisible by k. If it is, it means it can be a part of independent component, and if it is a if it can be a part of independent component, we will make it a part of independent component and make leftover as 0, right? So we'll just simply increment the result and say that this will be a part of independent component and there will be no contribution to its parent, and hence the leftover is 0, which will be contributed back to the parent, right? So after this entire thing ends, result will contain the total number of components from the children's. So finally we'll check if there is leftover with the parent as well. So basically after doing everything, can parent like the final root is also have some leftover, and if it has, then it will be a part of one independent component. Now notice that we might have to check whether it is divisible by 5 or not, or divisible by k or not, but it is already given in the problem that sum of values is already divisible by k. So basically we can always make we can always make components. So basically the leftover will surely be divisible by k. So finally we'll just run result as the maximum number of components that we can form. So if you have solved this problem, the next follow-up that you should try is figuring out what are the components, because here we have just merged the components, but if you try to solve for what are the components, you will get much better clarity on what's exactly happening inside the recursion, right? So hope you find it helpful. If you like the video, give it a thumbs up and do subscribe if you haven't already, and I will see you in the next one. Thank you.